Things are called transformation and translation. Sometimes gets mixed up. Transformation includes everything that we're going to talk about this whole chapter. This whole chapter is on transformation. It's something that maps a figure, which we call a pre-image. The pre-image is like what I fill out for you, the picture you start with. And then the new thing is called the image. So what you start with is a pre-image, and then when you move it, flip it, whatever, that is the image. A transformation can change the size, the position, or the orientation. So far, yesterday, did we change the size of the shape? No. Did we flip it at all? No, we just changed the position. Okay? This is like a slide. The translation that we did yesterday. A flip is what a reflection is. We flip it over a line called the line of reflection.
Very easy.
Like I said before, reflections, like you look at the mirror, if I folded this, it would fold right on top of each other. Each point and its image are the same distance. That is super important. Did anyone figure that out when they were doing that? Yeah, the same distance. So if I'm, let's say I'm a centimeter away here, I'm going to be a centimeter away there. If I'm 2 centimeters from my line of reflection to A, I'm going to be 2 centimeters from my line of reflection to my new A. It's always the exact same distance. Possible lines of reflection, we have our axes, x-axis. Remember that one goes up, down. Our y-axis, I totally just lied. That's so embarrassing. X-axis goes left, right, y-axis goes up, down. I'm sorry, I'm an idiot.
Can't believe you lied just like that.
I'm sorry. Our vertical lines, those are your x equals some number and y equals some number. That's what I was thinking of. I know you don't believe me, but remember when you have x equals something, those go up and down. When your y equals something, those go left, right. So you have like y equals 1. If this is your x-axis, y equals 1, it's a straight line like that. Then we have diagonal lines like the one you guys looked at, are y equals x and y equals negative x. Those go like that and like that. They have a 1 and negative 1 slope. So those are all the lines that we reflect over. They're either straight lines, the only diagonal lines we do are y equals x and y equals negative x. Okay, turn to your flip book. That very first thing, just take your cover off. Let's just fill this out. Reflection is a flip. We don't need to fill that out again. We already have that. Okay, so if I look at number 1, and I have this triangle here, I'm going to reflect it in the y-axis. So that's this line right here, my y-axis. I need to be the same distance from that line, okay? So if I look at A is right here. I'm 1, 2, 3 away from my blue line, true? So I gotta go 3, staying on the same y, this same line. I gotta go 3 this way. 1, 2, 3. And there is my new A. Okay, my B, I'm 1 away, so I gotta be 1 away here, so here's my new B. And C, we're 5 away, so 5 away over here. When I look at the coordinates, A prime's coordinates is 1, 2, 3, 1, 2, 3, 4, 5. 3, 5. What's B's coordinates?
1, negative 1.
1, negative 1. What's C's coordinates?
5, 2.
5, 2. we have this A is negative 3, 5. My new A is positive 3, 5. What changes?
Turns positive and switches
What does?
like it's
My X or my Y? My X, yeah, my X changes. Does my Y change at all?
Yeah.
No. So remember yesterday we talked about those rules? X, Y. In this instance, the only thing that happens is that my X becomes negative and my Y stays the same. So anytime you're reflecting over the Y-axis, you're just going to make the negative version of your X and leave your Y. Okay. If I reflect in the X-axis, why it literally just calibrated this. Frustrating. No, we're not going to do it again.
Why not?
Because if I do the same distance from my axis, F is 1 away, so we're going to be 1 up, which is right there. E is 2 away, so we're going to be 2 up. This is really awful. Etc., etc. You finish your picture. That was really bad. Sure, hopefully yours looks way better than that. What are D's new coordinates?
negative 4, 5, 4.
Negative 4, 5. Looking at my old D, negative 4, negative 5, what's the only thing that happened?
The Y changed.
The Y changed to its negative version, right?
Sure.
So XY, you're going to leave your X, and you're going to make your Y negative. So what would E, not looking at your picture, what would E's coordinate be?
Negative 3, 2.
Negative 3, 2. How about F?
0, 1.
0, 1. How about G?
Negative 4, 5. You talk. Sorry.
Negative 1, 4,
Negative
right?
1, 4. That's just it.
So it's kind of weird to think about, but when you reflect in the Y, your X changes. When you reflect in the X, your Y changes. You definitely don't have to memorize these rules. I kind of think it's easier to just count them away, but whatever works for you. Okay. When I look at number 3, I'm reflecting in the line X equals 1. X equals 1. Does that go up, down, or left, right?
Up, down.
Up, down. Up, down at X equals 1. Oh, see, now sometimes it works, sometimes it doesn't. That's weird. So that's my line X equals 1. So how far away is, where do you want to start? What
Q.
letter?
Q.
Q. How far away is Q?
3.
3, so let's go 1, 2, 3. That's my new Q. R is the same. It is.
Yes, it is.
No, it's
From X equals 1, not the axis, but from X equals 1.
not. It's 3.
Oh, yeah.
Because you moved the line. You moved the x-axis.
Because it goes from negative 2, so negative 2, negative 1, 0, 1. So 3.
Yeah.
R, how far away are P and S?
7.
7. So we're on that last line. So what is P's new coordinate?
6, 2.
Close.
7, 2. Oh, 8, 2.
8, 2. Yeah. So if I look at my other coordinate, negative 6, 2, again, notice your Y doesn't change. The only thing that changes is your X. Okay, in this instance, it's not just flipped because we're at we're at positive 1, not the 0. When we're at 0, you just flip it negative and positive. Okay, what is Q's new coordinates?
2, -1.
Q.
Q. You're right.
4, -1.
4, -1. What's ours?
4, -3.
4, -3. And S,
8, -6.
8, -6.
So you add 2 since the line is over. Whatever.
You add, well, like -6 to 8. It just depends on how far away it is. So there's no like set rule. Because like since Q is closer, it's gonna be closer here and here. Since P is further away, it's gonna be further away here and here. That's the same distance, but like you can't use like a +2 for each one or a +3 because this isn't the same distance. You should have to count. Okay, the last one that's kind of weird is this y equals x. Let's plot y equals x. That goes to 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. This nice little diagonal line
Wait, what?
that is not even working. Y equals x goes through 0, 0, 1, 1, 2, 2, 3, 3, keep going.
It's like this.
This one is a little bit harder to count, but we're still gonna count. Okay? Let's look at K. Follow on the diagonal. So this is like 1 box, 2 box, 3. So we go 1, 2. I think if I'm right, since my line is off.
Yeah.
I think we're at here, right?
Oh, yeah.
Negative
I
2.
could, yeah.
Here's the hardest one. J, follow your diagonal. 1, 2, 3, 4, 5. 1.
That one should be 7, -3.
Yes. So Bree says J is 7, -3. K, we said was 3, -3, right? Who's got L? Good news, we don't quiz test on y equals x, cause that sucks to count.
Okay.
First you need to make your line, like literally everybody else has.